Hello there, this is Cody Jackson, and this is another Python video for Cody Mom. Today we're going to be talking about pipes and conditional statements. You've seen it before, you'll see it again. If you want to follow along at home, the course that we're doing right now is coming from the Learn Programming in Python book with Cody Jackson. If you want to jump ahead and look at some of the more advanced stuff, you can take a look at Secret Recipes of Python Ninja. So, standard input and output. Because Python is built on the C language, and C has standard input, standard output, and standard error pipes or streams, Python has that functionality as well. So, what I mean by pipes and streams is, in Unix, everything is a file. So, when you are reading from a file, you're reading data from a network connection, and you're reading data from another program, it's treated as a file, and so it just kind of streams that data to whatever it is that's interacting with it. And you can pipe that data from one location to another. And you may have seen this before with the vertical pipe character, allowing you to take the output of one command and pipe it to the input of another command. So Python has that ability deep down to allow you to change the direction of where all of these data streams are going. So sysstandardin is the normal input stream for Python. So normally it's going to be taking a look at what's coming from the keyboard and do something with it. But you can also set it up to accept input from a file, from a network connection, or some other type of input like that. Sysstandardout and sysstandarderr are your standard output and error streams. Normally, the data from both of those goes to the monitor, but you can route either one of those to some other location, to a file, to a printer, to a network connection like a network drive, or something like that. If you get an error in your program, it's not standard output that you would think. It's actually coming from the standard error stream. And the benefit to that is you can have your normal output coming to the console and redirect standard error to, say, an error log for debugging and troubleshooting later on. One thing that I have found is you don't always know what data is coming over sysstandarderr. I was working on a project with a coworker at one time, and we were surprised to see that the output that we expected from the program was not coming to the terminal. We couldn't figure out where it was going. We eventually traced it down to the error log that he had set up. And so it was normal expected output, but for some reason the program was sending that data over the sysstandarderr pipe to the log, and not to the console as we expected. So that doesn't happen very often, and that might have just been because we were using Python 2.4, I think it was, and it's probably been fixed now. Just letting you know that, so in case you have problems with your code and you're not getting the results that you expect, you may have to investigate where your data streams are going and if they're piped to a different location. So I'm not going to dwell on that anymore. That was really just kind of giving you an introduction to the fact that if you need to, as you gain more experience, you can start messing with the underpinnings of how Python handles input and output and redirect it to other locations using the different pipes that are available. So we're going to talk about conditional statements. Conditional statements in Python are handled by if-else statements. So conditional statements in conjunction with loops are probably the most common data control structures that you have in any programming language. Basically what an if else does is asks yes or no questions. If this condition is true or not true, you can have negative checks in there, then do this action. If not, do this other action. And you can even have a basically like a final clause, like if none of these other conditions are true, then do this other thing as a last resort. When you are making your if-else statements, the only thing that is required is the very first if. You don't have to have an else. You don't have to have a final condition. You don't have to have anything like that. Similar to if-else statements is a switch statement. Python does not have switch statements or case, depending on the language that you may be familiar with. In Python, if-else performs the same functionality, and the designers did that on purpose because you can have one data structure, the if-else, performing your functionality of a regular if-else or a switch condition without having the extra logic in there to provide that. If you're not familiar with it, a switch or case statement is basically just a shortcut where you have a test a single variable you test a single variable against a bunch of different conditions, cases, and if it matches any one of those, then your programming logic is redirected to that new direction. So like I said, it's just like an if-else, except it shortcuts it a little bit. So in case you're kind of confused, this is an example of a switch statement. Up here we have the actual switch, and it is taking a look at a grade that is coming in to the data structure. So if the grade value that is coming in is a text string of A, then it prints outstanding and then breaks immediately out. If it doesn't match that and it matches a B, then it prints good job and breaks out, so on and so forth. If it doesn't match any one of those conditions, then it prints out invalid grade. And you don't have to have a break at that point because it's the default. And so if it doesn't match anything else, then it's immediately going to jump down to the default. So we jumped over here to the IPython interpreter, and we're just kind of looking at how a regular if-else structure works. In this case, I've defined a function. We haven't talked about functions yet, but you should be able to understand what's going on. So we define the function, give the function a name, and we are sending to the user a question: what is your favorite room in the house? That answer that they provide is captured as the input, and so that's what this input function is doing, is it accepts as an argument a question, or a text string really, captures that data from the user on the keyboard, and then assigns it to a variable. We've now got that variable answer, and then we compare it to a bunch of different conditions. So if the answer is exactly equal to the text string kitchen, then it prints to the screen, you probably like to eat. Elif, or else if, it's the bedroom, then it says you probably like to sleep. Else if, or elif, living room, you probably like the TV. So what you might see in other languages is it would actually have else if spelled out as two separate words. Python took a little bit of shortcut, combined those together into a single word, elif. And then down at the bottom is that finally clause that I had talked about, where it's just a straight else. If it doesn't meet any of these other conditions, then it will jump down to this and print basically the default value. We run the function fav room, and it asks, what is your favorite room in the house? Bedroom. And it says, you probably like to sleep. Exactly as expected. Fav room, none. Then maybe you prefer the outdoors. So what happens if we don't give it an answer at all? It jumps to the default value and says maybe prefer the outdoors. So in this case, whether or not somebody gives you an answer, you always have that default value that can come out. If we jump over to this is the dice roll simulator that I've shown before. This is a great example of using if-else statements to make different choices. So in this one, we have defined the random number generator function, and it's taken an argument, which is choice. In this case, choice is just an integer value, 1 through 7 in here. And it basically says, does the choice that's sent in, the integer value, match any one of these numbers? If so, then go ahead and roll the virtual die. If it doesn't match any of those, here's our default message. Then it returns should not be here, invalid choice, and then that is sent as the return value for this function, and ultimately it would be printed to the screen. So this is a good example of using a else statement with your entire conditional block. It helps you to verify that the data that's coming in is expected. It would capture anything else and then tell you this is a bad value. I don't want to talk about cybersecurity a whole lot, but one of the issues of malware attacks and website attacks and things like that is not verifying the data that's coming in. So, for example, if you have something that's called a SQL injection attack, where a website has a form and somebody is able to put a SQL query into that form, by default that SQL query is going to be ran by the form, sent to the database, and executed. And they can go in and they can drop tables, they can manipulate data, stuff like that. Data validation comes in where it says this form should only expect numbers, integers, for a phone number. If anything else is put in there, text characters, special characters, anything like that, I'm going to ignore them. Or spit an error saying, please input integers. So if you're on a web page and you see a web form that says, input your data in this particular format, say a phone number, it has to have the beginning parentheses, 3 numbers, an ending parentheses, 3 numbers, a hyphen, and then 4 numbers, then that's what it's doing, is that is the code that is on the back end. And if it doesn't match that exact formula, it's going to kick it out as a bad answer. What we're doing here with all of these is we're looking for those specific numbers and doing something with them. Everything else is caught and delivers an error message. So this is a simple version of data validation. And it's just a good habit to get into when we're talking about secure programming and things like that, is validating the data that's coming in. That's most important when we are talking about data that you don't control. So pretty much anything that's coming from an external source or a user. You need to validate that data and make sure they're not trying to break your system. If it's data that you generate on your own, then you're okay, and you can generally get away with not doing a lot of data validation. But it's just a good habit, and you might as well do it with everything, because you never know when you're going to get a bug in there, or if somebody gets a hold of your code and sends out an update to everybody else, and they think that it's correct information and stuff like that. That's a whole different topic, and so I'm just going to leave it right there for now. So now if we come back to our C switch statement where we talked about previously, you should see that it looks very similar to what we did with the if-else statements interactively. We're just capturing some sort of a variable, and we're testing it against a bunch of different conditions, and if it matches one of those, then we go off and do something. If not, we have a default value that's captured and provides that. Again, you don't have to have anything beyond that initial if statement. Elifs and an else, not required, but good programming habit. In Python, you can kind of sort of use a dictionary as a switch. It's not common. I can't say that I've ever seen it in the wild, but I do recall reading it in a book, and so we'll talk about it here. Just something to put in your toolbox. So dictionaries, as you recall, have a key and a value that is associated to that key. If you do a comparison against key values within a dictionary, then that kind of gives you the functionality that a switch does. You can also do a search within a list by index number or actual values that are within the list. One reason to do this is because lists and dictionaries are built at runtime, so they can be more flexible. They're not always created by the programmer ahead of time. They can be built programmatically by the computer as it's running, and it brings in data. It can populate that dictionary. So jumping back to our interpreter, this is an example of using a dictionary to function like a switch. So in this case, we have a variable it's been defined with the text string spam, and we're basically comparing it to a dictionary. Dictionary uses curly braces, so this portion right here is the dictionary, and then we are providing our choice outside of that dictionary. So basically what we've done is we've defined a dictionary, and then we are going to capture the choice variable as the key, and whatever the value that matches that key is going to be printed. We compare choice to all of the keys in the dictionary. It matches spam, and the value for spam is returned as 0.35. What is more common to see is a dictionary formatted like this, often all in one row, or it can be stacked vertically. Depends on the preference of the programmer and what makes more sense. But anyways, dictionary is defined, and then we have our dictionary, and then we provide it with the key that we're looking for, and it returns the output or the value that's associated with that key as the output. So this is one example of how you can basically use a dictionary as a switch if you want to. But like I said, if-else statements are more common. So that's it for conditional if-else statements and data streams and the piping of those data streams to other locations. So we did take a look at the standard Python data streams, standard in, standard out, standard error. Talked about how that data can be moved to different locations by piping it to files, network connections, things like that. We explained how the output data that you would expect to see on standard out could actually be handled by standard error. So if you're not seeing the values of the data that you expect, take a look at your standard out and your standard error streams. It may be going to a location that you don't expect. We hit if-else statements, how they can direct flow. They're basically just a straight comparison. If a value matches the incoming condition, then it's going to go ahead and do whatever logic you tell it to do. We haven't done anything significant beyond just printing values to the screen, but later on we will show much more significant actions. We also discussed alternatives to if-else statements, so that would be the switch if you're using another language or using a dictionary like a switch in Python. Next time we are going to talk about loops, which are another main player in getting programs to work, because they basically allow the computer to either wait for input or continue actions over and over again. This is basically where we get into the automation of functions and getting programs to do a lot of that automatic action that people love computers to do for them. So I hope you enjoyed this video, and until next time, keep learning, keep practicing. If you have any questions or comments, please let us know. Thanks, and we'll see you next time.